Okay, so welcome back. So now we are going to start getting into the details of what exactly is going on. What exactly is the interpreter doing? So we know we have this variable that we call x. We can set a new variable w, and if we type w equals true, we've created a new variable called w. But what exactly is being created by Python? And so it's really important to understand these details, because if you can understand these details, it makes it a lot easier to figure out programming and figuring out how to use new to use pre-existing code and to use new code and to use new modules and very useful things. So we are going to learn two new functions. One is called type and the other is called dir. So if we type, so again, it's a function, and so the syntax in Python is that you have to have a open parentheses and a close parentheses, and you have to supply the arguments to the function. And so the arguments that type takes is a variable. And so we see it prints out something brand new, and it's in these open and closing brackets, and then we see something called a class, and then we see something called a bool. So you might recognize bool is shorthand for Boolean, and so what we've created is a type of object that is either true or false. We can also see what x is, again using the type, and we see that everything is the same except for what is after the class. So we see the open and closing brackets, we see something called class, but now this is int. And so we see, if we play around with this a little bit, that we can create things that are of different class. So we've seen a Boolean type class, we've seen an integer class, we've seen a float class, and now we've seen a complex number class. So what Python is doing is a little bit more complicated than you first might appreciate. So when we type these things in order to create a variable, Python is trying to infer what type of thing we're trying to create. And so, you know, if we type something like this, y equals 6, where we don't have any sort of decimal, it thinks, okay, we are probably trying to create an integer object. And so y is created as an integer object. If we add a decimal, so if we say x equals 5, and even if we don't include any decimal, but the presence of having that dot, Python is trying to infer, okay, this person is probably trying to create a float. And so we are going to store x as a float type object. You might remember complex numbers from your high school classes, so imaginary numbers. So this, typically you used I as the square root of -1, but the way Python works is that it actually uses j to designate that it's an imaginary number. So, you know, you can have some sort of, if you remember your imaginary math, where I squared is equal to -1, you can do these sorts of multiplications, and so Python is able to do that. So evidently we can create different classes of numbers. So Booleans, integers, floats, and complex numbers are all things that we saw. So these are the main numeric types supported by Python. So you can create an integer, which does not have a decimal. You can create a float, which has a decimal. You can create a Boolean, which is just equal to true or false. And then you can also create an imaginary number that also includes the square root of -1 as a value. So the class, so this is created this way because Python is what's called an object-oriented language. So object-oriented programming is a very common programming paradigm based on the concept of objects. So these data structures, these are specific data structures that hold both data, and then they also have the ability to do certain things that are useful to the object, or useful to the class. And so these are called attributes. And so these are like functions. So we saw before what a function was. We've seen this type function. We've seen this dir function. But there's also functions that are actually tied to specific objects. And we'll see why this is really useful soon. So when we do something like this, what we're doing is we're creating an object. So x is an example of an object, and x belongs to the integer class. Oops. And x belongs to the integer class. So there are 5 definitions here that I list that are very useful for you to memorize. So a class is a general template for creating an object. So integer is an example of a class, and this class understands integer types, and it contains both attributes, data, and functions necessary for representing that object and also for manipulating that object. An instance or an object is a single version of the class. So we can let's create 3 different versions of the integer class. So x equals 6, y equals 8, and z equals 3. So all 3 of these variables are integers, and so we've created 3 different objects of this class. So class is kind of like a template for creating this, and then objects are actually instances of that class. Attributes, so attributes are the data for the class. So in this case, 3 is the data. So every single instance can have a different value. So, you can have something that's like w equals some crazy large number, and the idea behind this is that w, so each one of these instances can have a different value. So an attribute basically is that specificity that tells you how each of the objects are different. So in this case, it's just the value of the number 683, 3 quadrillion billion, whatever that number is. So the attribute is this would be 6, 8, 3, etc. And then a method is a function associated with the object. A method operates on parameters. So a method knows the attributes of the object, so it knows the numbers, and then it does something that might be useful to do it. Okay, so let's see what this means in a second. So if you want to see what all the attributes and the methods are, you can use this function dir. So this is the second function that becomes very useful to know. So dir lists all of the attributes and all of the methods of an object. So we can see that there's all of these different things that have like 2 underscores to start and 2 underscores after it. So these are called magic methods, and we'll get into that in a little bit, what exactly these do. And then we also have a bunch of names that are kind of more straightforward. So as integer ratio, and these are all separated by commas right here. Y equals 0.25. Let's make z equals to 2 plus 3j. And so what you'll see is that these are not exactly the same. So x is an integer, y is a float, z is a complex number, an imaginary number. And some of these methods and attributes are the same. So you see the absolute, so ABS is short for absolute, and you see all 3 of these have this. But as integer ratio is one of the methods of the integer class, but we do not see it in the complex number class. But we do see it in the float class. So you can see they have, some of them share the same methods, but some of them are unique to kind of each of the different classes. So it's kind of surprising at first just to see how many methods and attributes are associated with each variable. So when we think, oh, x equals 8, we're just creating variable, what we're actually creating is much more complicated. So Python creates something much more complicated that not only has the number 8, but it also has all these other things that kind of go along with it. So I know this seems strange, but it's essential to start to think about things in this way. So objects, it's paramount, objects are paramount to Python, and thinking about these things as objects is really the only way to get really comfortable with programming in Python. So how do you call one of these attributes or methods? So this is where the dot operator is used. So the dot operator is simply a period, so if you just use the period. So this is how you access the attributes and methods of a class. So if I wanted to see the real value of z, I start out with the object that I'm interested in, so the variable name is z, and then I can type this right here, so z.real, and so now it prints out the real part of the z number. If I want to see the imaginary part, then I see 3.0, so this is the imaginary part of the z number. So these are both examples of attributes. So why are they examples of attributes? They're examples of attributes because these are data versus functions. So methods are functions. So how do we determine the difference? So when we try to do x.conjugate, so conjugate is also listed as part of the complex number class, sorry, z.conjugate. So, we see conjugate is there, but it's a built-in method. And so what this error is it's telling me you can't use this unless you have parentheses. So just remember, functions always have to have parentheses. And so methods are the same way. So if I want to call this method, I have to include parentheses. Oh, I misspelled it. So that's called an attribute error. And so now I get the conjugate of z. And if you remember your imaginary numbers, that's just you take the imaginary value and multiply it by -1. And so this is just a way to get the magnitude is by multiplying it by its conjugate. But this isn't really important. So you can't really tell by using the dir command whether or not something is a method or an attribute, whether it's data or a function. But if you try to run it without parentheses, you'll get an error. So you can also try to do these magic methods, and so you call them just the exact same way. And so use the dot operator, and then we do __ abs __, but this is a method, and so I get an error, and so the only way I can use this is by including the parentheses. And so the absolute value of this is actually just the magnitude. So if you take this and multiply by the conjugate and then take the square root of it, that's the same of what this absolute here does. You can also do things like add numbers together. So we have x, we have y, we can add x and y together. And so the way this actually works is that you use these magic methods to do it. So there is a method of x called add, and we know it's a method because if we don't use the parentheses, we get an error. And now if we use the parentheses, we do get an error, and the reason we get an error is a new type of error called a type error, and the reason is because it expects an argument. So this particular method requires having an argument in order to work, and of course that makes sense. If you want to add x and y together, then you need to do it. And so unfortunately I chose a poor example here. I should have made y equal to a integer, and so now I have x and I have y, And if I try to use this method here, this magic method here, then I simply add 8 and 3 together, and it works. Okay. Similarly, if I try to use parentheses on an attribute, I get an error, and that's because a float object is not actually callable. So a float object, you can't call a float object as if it's a function. So attributes and methods are separate things. One is kind of data, think of it like as a noun, and then the other one is a verb, and it requires the parentheses to provide it with arguments. You can also, so we've seen that Python tries to infer what sort of object that you want to create. So when we create X, this is called the implicit method. We are not telling Python what sort of object to create. It just infers that we probably want to create a integer object when we do this. And so as a result, we have a class, an integer class is created. But let's say we wanted to be explicit about what we want. So we can also use the name of the class. So the name of the class is int. And so now when we put the number in there, we explicitly create a class integer type. But we can also do something like this. And so now we're creating a float object instead. So X is a float object because we've explicitly told Python exactly what type of class we want to create. So we said create a float object and store it as X, and the 2 tells us what kind of data we want to store in it. So now it's equal to 2.0. So if you remember, we also had this complex that could also hold imaginary numbers. And so again, you can take the name of the class and then give it that. So now we've created a complex number that has a 2 for the real part, and because we did not provide it with a imaginary part, it's automatically set equal to 0. But we could also do something like this where we provide 2 different arguments. So now you'll note that there's a comma that kind of separates them, and so now we've created an object that is 2 as the real part and 5 as the imaginary part. So this is explicitly versus implicitly creating instances. So implicitly, we don't tell Python what to create. It just tries to infer that. And so typically we use the assignment operator. Sorry, typically we just, the assignment operator is just, we provide it with some sort of like number. But if we want to explicitly tell it what to provide, then we give it the name of the class. And then we have the object that we specify. Okay, so that covers kind of the basics, and then one final thing we are going to cover. So we have been using this as the interpreter this whole time, and we've been entering commands into the interpreter. But one final powerful thing that we can do is create scripts. And so scripts are code that are saved, that are commands that are saved in a file, and then you run the entire file together all at once. And so any of these commands right here that we have, we can also put into the script. So let's give this script a name. So we're going to save as, and let's call it, so let's put it in our, we'll put it in our home directory for now. And then we'll call it firstscript.py. So I like Sublime a lot. That's the primary text editor that I use. If you don't know what a text editor is, then you should start using Sublime for this. If you have another text editor that you're already comfortable with, you can certainly feel free to use that text editor. So one of the things in Python that you always do, when you name the script, you always give it a .py extension. And this is just similar to like Microsoft Word docs always have a .doc, Excel files have like a .xlsx, etc. So Python, the way the computer knows that it's a Python script is that it ends with the .py extension. And so now we can take these different commands, y equals 2, that we put in the interpreter, and we can put them in each line. So here we have explicitly created a complex number z. Here we create a integer y that's equal to 10. Here we create an integer that is equal to 6. And then here we created a new integer called w that is equal to x plus y. So let's see what happens. So we save this file. And so now if we want to run it, note we've exited the Python interpreter. So you do not run a script from the Python interpreter. So if you try to run it from here, you're going to get an error. You actually run a script from the command line. And the way you run the script is that you still use Python 3. So normally if you didn't supply Python 3 with an argument, it would just go directly into the interpreter. But if you give Python 3 an argument, it, instead of going into the interpreter, it simply prints out, it simply runs the script. And so we can see it ran the script, and let's see what exactly it did. So first it set z is equal to this, and it does not print anything out. Then it sets y equals to this, then it sets x equal to this, then it sets w equal to this, and then here it prints w. So the first thing that gets printed is 16, so w equals x plus y, 10 plus 6, okay, that checks out, so we see 16, and then it prints z, which we set is equal to 2 plus 5, j. So everything makes sense, and so we can also see why you would start to use the print statement. So the print statement is useful because it prints information from a script that we normally don't have access to the standard out, so that we can see it on the screen. All right, so that is the basics of how to run Python, in a very basic way. We haven't done anything interesting really yet, but hopefully you start to get a flavor for how the object-oriented part of Python works, and you start to get used to using those commands type and dir. Those are really important commands to get comfortable with as we move into more complicated coding. Finally, just some basics on help. There is a help page for Python that you are certainly welcome to use. So for example, like this lists the different numeric types that exist in Python. If you wanted to find more information on magic methods, you could, for example, go here. So these are all the different magic methods that are used, and we'll get into this in a little bit more detail. And then the other thing that you should always get used to is just using Google. So if I take an error and then I type it in, you'll notice that there's this website called Stack Overflow, and Stack Overflow is just a great way to get information on troubleshooting. So one of the things you can do is post questions on Stack Overflow, but typically someone has already posted the question that you have. And so, they have all of these questions that you can take the errors, for example, and just paste it in, and then you typically get something useful that'll help you figure out maybe why my program does not work. All right, that is the end of lecture 2, and we will continue lecture 3 next.